This is my Power Designs 2K-10 0 to 2 kV 10 milliamp high voltage lab power supply. Probably built somewhere in the, I don't know, 70s or 80s. So I thought we might just make a quick little video taking a look under the bonnet. On the front panel we have the output voltmeter there and a selection switch to measure output voltage or output current. We have the decade box of knobs to let us set the output voltage across 3 decades. We have the main switch and fuse, a couple of neons. So let's have a look inside. Now under the bonnet we have some nice old school rivet board construction with no copper laminate on the fiberglass board. Here we have the feedback voltage regulation stage. We have a stack of high precision 0.1% resistors set up on the rotary switches. We have the voltmeter, we have the neons which I've just replaced, the mains input cable which I've just replaced, nice high voltage capacitor there, nice vacuum tube which is probably used for, I don't know, some sort of high voltage rectification probably. That's a high voltage resistor of some sort, I believe. Some of this stuff's a little bit dusty and grubby as you get in any high voltage system because of electrostatic forces. I probably need to clean that up a little bit, it wouldn't hurt. Have some old school TO5 CAN transistors here. Some of those have 6 pins. They may be either very old school op amps or possibly matched transistor pairs in a 6-pin package. Lovely old school construction of discrete components. High voltage capacitor here, big fat bleed resistor across the cap and a little neon bulb to give you an indication of when it's charged for safety reasons. High voltage transformer here. Another cap here. We have the output stage here with a rotary switch to let us select either positive or negative polarity on the high voltage output. So you can have, up to 2 kV, negative 2 kV relative to ground. So it's essentially bipolar, selectable. This is the output terminal here. That's actually an MHV connector, which is sort of like a BNC connector but designed for high voltage use. I often see these in things like Geiger counters and that sort of instrumentation where you've got a very high voltage on a coax cable. Back to the power circuitry, the high voltage cap again. These are actually oil-filled PCB capacitors from the 70s. So they're a little bit of an environmental hazard if you dispose of them in landfill, but these ones are in good condition. They're sealed, they're not leaking, they're still quite serviceable, so at the moment I'm leaving them in service and we'll dispose of them properly at the end of their service life. Pot there for fine trimming of the output voltage and an overload indicator lamp on the front panel. I don't know what that is, possibly some sort of high voltage rectified diode, I'm not sure. So let's fire it up and see how it goes. So we're now on. We have the indicator neon lamp is on and the tube heater filament is on. So we have a lovely warm glow from the unit when it's turned on. Now the overload neon lamp is on. I'm not really sure why that's on. At the moment the high voltage output is turned off. If I put the output meter into current mode, there is no load current, so I don't know why the overload lamp is on. But let's just try. I've currently got it set for 900 volts DC. We'll just try turning on the HV. and we're now on at 900 volts, give or take just a tiny touch. That's about 900, pretty clean. Now, just for test purposes, I have here a scintillation detector, a little sodium iodide detector, and I just thought that this might give us a good excuse to test the high voltage supply. So I've just capacitively coupled its output with a little bias T with a 2kV ceramic and a couple of resistors, and let's see if we get an output. So we're getting some pulses from the scintillation detector, probably just from background radiation or cosmic rays. Pretty fast pulses there, so about on the order of 10 microseconds. But there's a distinct train of pulses there coming in pretty regularly with differing amplitudes, which is what you'd expect for different photon energies. That's not a bad pulse amplitude actually. That's straight off the photomultiplier tube with no active amplification or anything. Just to prove that I'm not faking, let's just try measuring the current output. Even with the PMT connected, the current is negligible. I believe this one has a fairly high resistance in its dionode chain. So let's just try. Now the overload LED is off, the overload neon, sorry, so that's probably just due to charging up the main capacitor. It probably comes on at the start while there's still charge going into the tank. And now it's flickering a bit, I'm not sure what the problem is there. So now let's turn the HV off and the overload lamp comes back on. Don't know what's going on there, but we're now down to 0 volts. Back to the scope, and we've got nothing coming out of the PMT. Let's just try that again. I'll turn on the HV, and we're now back to getting pulses. Cool. Bit of a discharge there in the cap. So there you go, Power Design's 2K-10 high voltage DC regulated lab power supply in a nice big heavy 2-unit rack mount case.